Alright, for this video I'm going to do some things just a little bit differently. I'm going to go through these three examples and just go for getting this method down. So in each video or in each example, feel free to pause the video and try to go a little bit faster than I am. I'm going to jump right to this b over 2 term, take the middle term, divide it in 2. Do not forget the negative in this. So this form of the equation, remember as you go to your completing the square, is always going to be x plus whatever your b over 2 term is, if I can get this to work, squared plus some extra value. So I can see right now I've got x minus 8x. Like I said, I like to personally put this in parentheses first. To complete the square, you're going to, and you can prove this to yourself, you're going to you're going to FOIL this out, distribute this out, and you will get this sum term here, which will come from this b over 2 term. But I'm just going to set this up with the plus the 3 minus whatever this has to be. Okay, so the term that's going to go here is going to be whatever your b over 2 term was squared. In other words, the 16 squared. Now, don't worry about the negative because you're squaring it. The negative will cancel out anyway. For consistency's sake, I'll put the negative in, but it really won't matter. If this number is the square of whatever half of this number is, you always have a perfect square trinomial. So, oops, forgot a squared here. All right, you're always going to take whatever this first term is without the squared, whatever operator or symbol you're using here, if it's a positive or a negative, will go next. And then whatever this term is here without the squared. Okay, in this case, maybe I shouldn't have used the negative just because now I don't want to double count it, but whatever that number is without the negative. And then it'll be squared. I would very much like for you to FOIL this again and see if we get this. This gives us, based on our first two terms, what the perfect squared trinomial would be based on those first two terms. But we changed the value of our entire function when we did this. We added something in we didn't have before. And that's why here on the outside, we have to turn around then and subtract that term. So here I get this will be equal to x minus 4 squared minus 13. This is what it looks like when we're completing the square. In this case, my b over 2 term is going to be a fraction. I wanted to show you a couple of fractions. So as I get this set up, I've got x squared minus 3x. And then we're going to add this 3 halves squared. Let's see, that didn't quite work out as a negative. Here we go. But because I changed the value of this, I need to turn around and subtract that 3 halves squared. I personally don't go ahead and simplify this because I would just need to factor it back out again. I'm going to go to an x minus my 3 halves squared to go from my perfect trinomial, perfectly squared trinomial, to this other form for it. And now, let's see, put some parentheses around here. Now I'm going to go ahead and simplify what's on the outside because I want to put this in as one number. Remember when you're squaring, square your numerator and your denominator separately. We're going to have a 9 over 4. In other words, 3 squared over 2 squared. I need a common denominator to put these together. So I'm going to kind of cheat here. 4 over 4 is the same thing as 1. This will give us x minus 3 halves squared minus 5 fourths. And here is our perfect trinomial. Last one, gave myself another one that had, or would give me a fraction for this term. I personally, by the way, prefer to leave these as fractions. To me, it's a little bit less work for what's coming up, especially when you get to this idea of squaring here. I think it's easier to square a fraction with the numerator and the denominator than to square a decimal. So, to get this set up, I'm going to take my first two terms. I'm going to get those set up. I'm going to be adding something here on the inside, and to compensate for whatever I added, I'm going to subtract it out here. This number, if it's half of whatever your middle term was, squared, will always give me a perfectly square trinomial. And whatever I do on the inside of the parentheses, I have to subtract the exact same thing outside the parentheses. So, I now have x plus 5 halves, all of that quantity squared, minus 8 minus, this will give me 25 fourths, so my common denominator here is 4. That'd be giving it the same thing as 32 fourths minus, or negative 32 fourths, minus 25 fourths. Which I then can put into a one common fraction here at the end. I'm not sure, I think I've run out of room. That's supposed to be a 4. Okay, so going through the methodology on this, I recommend that you find a couple, or make up a couple of examples for yourself and practice completing the square on them. We'll get into the calculus in a little bit of where this comes in handy.